The reflection of sound. Sound is a wave, and when this wave encounters sudden changes in the medium, the wave reflects off these changes. For example, a sound traveling through air, if it suddenly meets a hard, flat obstacle like a wall, will reflect off that obstacle. It is interesting to note how similar the behavior of sound reflection is to that of light reflection. For example, the angle made by the incident wave to the normal is equal to the angle made by the reflected wave to the normal. Also, the sound gets reflected off flat, hard surfaces the most. For example, a large wall or a large rock. Echo. An echo is a name given to a reflection of sound that fulfills certain requirements. We perceive the echo of a sound if it takes a definite time between the production of the sound and its reflection to reach us again. In fact, the time delay between the production of the original sound and its reflection has to be approximately 0.1 seconds in order for us to perceive the echo properly. If we think about the speed of sound, which is approximately 340 meters per second, that means the sound has to cover a total of approximately 34 meters from the beginning to the end of the reflection in order to be perceived as an echo. In other words, the obstacle that is creating this echo has to be at least 17 meters of distance from the source of the sound so that the echo can be heard clearly. This consideration of distance and the nature of the obstacle becomes important when we are building structures that either require the formation of echoes or must discourage the formation of echoes. If we want to be clearly audible, it is best to suppress the echoes, in which case the obstacle will be made out of sound absorbing materials, as well as the distances will be made in such a way so as to minimize the chances of an echo. If echoes repeat again and again, the phenomenon is known as reverberation. Reverberation is often seen in enclosed structures such as stadiums or concert halls. What happens is that the same sound gets reflected back and forth by different surfaces so that we hear both the original sound and the persistence of these reflected sounds later. In order to create an echo, we need large flat surfaces which are parallel to each other, which can reflect the same sound back and forth again and again. Reverberations can be useful to us, they can also be a nuisance to us depending on the specific application. Applications of multiple reflections of sound. There are many devices like megaphones, loudhailers, shehnais and trumpets which use a specific structure in order to concentrate sound in a particular direction. They do this by creating a conical structure in which the sound gets reflected inside again and again until it can be focused into a very narrow region of space. Another application of multiple reflection is the stethoscope. Doctors use this instrument in order to hear sounds inside the patient's body. Most importantly, breathing sounds and heartbeats. The tube connecting the sound receiver of the stethoscope to the doctor's ear contains a narrow channel through which the sound wave reflects multiple times before reaching the doctor's ears. A third application of multiple reflection is in the design of concert halls and sound booths. These structures are specifically built with special large boards called sounding boards. These sounding boards are curved in a very specific way so as to channel sound in specific directions. In a manner similar to a mirror, these curved sounding boards are reflecting sound in one particular direction to maximize the echo or reverberation in that particular direction. In order to suppress an echo, we can use various kinds of sound absorbing materials. In order to promote reflection, to promote an echo, we can use hard, smooth and tough materials like metals or concrete. The range of human hearing. After a lot of experimentation, we have discovered that on average, humans have a very limited range of frequencies to which we are sensitive. It has been noted that humans usually cannot hear any sound which is below 20 Hz and cannot hear any sound which has a frequency greater than 20,000 Hz. So the region between these two limits, between 20 Hz on one end and 20,000 Hz on the other end, characterizes the audible range of frequencies for humans. Please note, the range of sounds that we can hear decreases greatly with age. Toddlers and small children are much more sensitive to low frequency sounds than adults. It has also been noted that many animals have a much greater effective range of frequency compared to humans. For example, rhinoceroses and elephants can communicate with each other with frequencies as low as 5 Hz. Frequencies which are below 20 Hz have a specific name. We call them infrasonic sounds, which means that these animals like rhinos and elephants are communicating using infrasound. At the other end, there are several animals like whales and bats and some species of birds which can produce extremely high frequencies of sound greatly exceeding 20,000 Hz. Sounds above 20,000 Hz are called ultrasonic sounds. Bats and whales routinely use ultrasonic sounds in order to communicate and to navigate. Applications of ultrasound. Ultrasonic sound finds many applications in medicine and industry. Let's go through a few of these one by one. In industry, many pieces of equipment which cannot be cleaned by chemical or physical methods are cleaned by exposing them to high frequency ultrasonic vibrations. These vibrations dislodge tough, hard to get pieces of dirt and other particles from the surfaces of machinery, thus rendering them clean and bright. Another major application of ultrasound is in imaging metallic objects and machinery for flaws. Ultrasonic waves travel through metals rather easily, but also reflect readily from any internal flaws or cracks in the material. Such reflections can be gathered by a sensor and produce an image of the flaw or the imperfection. So ultrasonic sensors are used for checking the quality and the integrity of critical machine parts like turbine blades in aircraft and the hulls of submarines. Ultrasonic sound also finds many applications in the medical field. Ultrasonic waves can penetrate deep into the body without damaging tissue. These waves can be used to reflect off various body parts like the organs and detect problems inside these organs like tumors, void air spaces and infections. Ultrasound has also been used to target hard to reach problems like gallstones and kidney stones. The ultrasonic waves actually break these stones down into much smaller pieces which can then be removed from the body through normal elimination. Procedures like the echocardiogram and the echosonogram also use the reflection of ultrasound waves from various parts of the body like the heart and the internal visceral organs in order to diagnose and treat various physical problems. Sonar. Sonar is an acronym which stands for Sound Navigation and Ranging. At sea, we can use special devices called transducers which produce short, sharp pulses of sound. These sound pulses travel through the water and then reflect back after encountering an obstacle. Since we already know the speed of sound in water and we can calculate the time that it took for a sound to travel to an obstacle and the time it took to come back, we can use this information to find out the depth of the sea floor at a particular place. To give you a practical example, let us say a sound pulse is fired towards the bottom of the ocean and the echo comes back approximately 10 seconds later. Since the time taken for the sound to get to the bottom and to come back is approximately 5 seconds, we can multiply this value with the speed of sound, which in water is approximately 1500 meters per second, and this will give us the depth of the water at that point.